G'day, we're going to clean and fix this carburetor on the Quad Runner LT F250 1996 model. This is the carburetor. As I've removed it from the bike, I've given it a little bit of a spray down on the outside to remove some of the loose grease and dust from it. On this side, this is the cover. This is where the covers come off for the throttle cable. The throttle cable loops in there. That little brass retainer fits in that hole, as I was pointing out. Cable comes in from the top here. This is the top, and the choke fits in this hole here. The fuel line attaches here. The petcock, I think it's a pulse line to the petcock as well, is there. This is the pulse line for the fuel pump, and there's another line on the back there that heads up over the top of the fuel tank to a little T-piece on the tube. Doesn't seem to go anywhere in particular. I wondered whether it was there to suck fumes from the petrol tank back down there. I'm not sure. It wasn't connected like that on this bike, and this bike is in fairly... this adjuster on the bottom here adjusts the idle. It just screws in and out a little stop in the bottom here, which pushes. That's in the closed position there. If you wind that screw in a bit, it pushes that butterfly up a little bit, opening it, and increases the idle speed. But we'll be taking that off in a minute. First of all, to get things started, and yes, this is different to the carburetor I disassembled for my other bike. If you take this top off, the carburetor sits flat on this surface, so that pipe can't have been there. I've got an idea it came out the side somewhere else. There was two tubes, but not in the top like that. Anyway, I can't do much with one hand, so first of all I'm going to remove these 4 screws around this top and show you what's in there. One of these screws in the top was very tight. They're all very tight, but this one was going to damage the Phillips head, and so I've gone and got the multi grips, vice grips, and gave it a tweak with that, and that's cracked that screw open. So the screw can be used again. I avoided damaging the Phillips head. I just felt it was about to burr right over, so I stopped. Okay, this lid's come off. Had 4 quite tight bolts in it, and that uncovers the diaphragm here, which the lid is a little bit spring loaded, because this spring, quite a long spring like that locates on the lid and goes up inside there, is there. And now this diaphragm will unpick from the edge there and come out. You'll notice later when we're putting it back in that there's a little bump on the edge here and a little bump on the body of the carburetor where that bump lines up. It's only subtle and it can be easily missed, but that's what it is. Now, this is the Venturi sliding mechanism, and I'm pulling it up and right out. You'll see that includes the whole slider, and this needle, and the thing to look for with this diaphragm is whether there's any tears in it. This one looks okay. It was okay on my other bike, and it's all fairly clean. The needle in here can come out. It comes right out through the centre there. I'm pushing on it there, and I'm going to drop it out on the table. So let's have a look at that. It's it consists of a cap that the spring presses on. Then, if I can focus on that, it's not focusing very well. There's a little circlip on there and a series of slots in this needle that the circlip can move to. Now that looks like it's in the standard factory position. I doubt whether this has been ever opened from what I'm seeing at the moment, and the very tight bolts. So I'll just put these parts aside. There's parts like this come in the new kit, a new circlip at least, and a new needle, but it's possibly unlikely that we need those parts. I'm just going to inspect things as I take things apart now. I'll put that in there, and that little cap, and yeah, that's the camera focusing better. Looking in that dish, you can see the grooves in the end of those, in the end of that needle there, that circlip can go to. But as a rule, I wouldn't be mucking around with that stuff unless you're in different altitude locations and things. It's leave well alone. It's not going to stop your bike running. So let's move on. The next stage is going to be to remove the 4 screws attaching the float bowl on the bottom, and it includes the wire that holds this idle adjuster, and we take note of where that is because it's a bit confusing trying to put it back later on as to what corner it came off and in what orientation. So we will do those 4 bolts. We'll see how tight they are. Okay, we're inside the float chamber here. Now, just one of the screws that came out, the one that's on the wire, is longer than the other 3. And remember that that screw goes in this corner, which is opposite the idle adjuster, because the wire comes up in this area here. And the next thing I'm going to remove is the idle adjuster. I think it basically just unscrews out of there. There's a spring and maybe a O-ring on the bottom. I'll do that now. Camera stopped strangely then. This pin that goes through this float hinge needs to be tapped on and knocked out, and we'll see how much pressure that requires to get that to happen. So a relatively light tap has been all that's required to knock that pin out. It once started, it will come all the way out, and that then releases the floats here, and the top of the float, this little tab on the top of the float, can be adjusted, bent a little bit to change the operation of the needle valve, that little flap presses on this pin here, and that pin is attached to the needle valve. I'll just grab it with the pliers here and lift it up. That there is the needle part, needle and seat. This is the needle, and the remaining part in there is the seat. It's secured by the little screw down this side around here, and I'm going to take that out and then give this needle seat a bit of a wiggle and lift it up. So that's the seat from the needle and seat come up and out. It's got a gauze mesh on the end of it there. It's not really in focus, maybe it's better there in focus. It looks a little dented. It's normally a dome shape, but I'm only going on what I know from looking at others. I was surprised to see the top of this seat, the brass part of it was quite black looking at it before I removed it, and when it came out I saw that, I'm thinking looked like it was made out of plastic, but it's brass like I'm used to seeing, and that the replacement one will be brass. So yeah, I've lifted that up. If you're following from that hole, it's got the O-ring on it that seals it in there, and as you can see the top of it's quite black. That might have something to do with the type of fuel that's been swishing around in here, but anyway, that's out and we'll move on. Next I'm going to remove this, I think that they call that the main jet. It's over the top of the venturi, and the needle valve goes up and down inside the end of this one, and that's just one of the jets. There's another jet in here that we can remove, and there's a I think they call this the pilot jet at the back there, which are all accessible from this side. This one's on the outside. It's the one that is wound in a couple of turns, and we're going to look at how far that's wound in, but that adjusts the initial amount of fuel I believe the engine gets. I'm not actually sure whether it's high, low, or mid-range jetting is associated with that pilot jet, but we'll be checking it out. And then on the other side there's another jet hidden down the hole near my thumb here, which is also supplied in the kit. Look, I'm unlikely to be changing those because I don't want to resize them, and unless they're seriously blocked, I think they'll be just given a bit of a shot of cleaner and replaced. The main thing I'm expecting to change is just the float valve, or the needle and seat here, and the rubber gasket that runs around this one. There's little else in the carby kit that I think will be required. This is all looking pretty good, and we'll be putting a few parts in it and then putting it back together. Okay, the next part of this exercise is to have a look at the jets. Now, it's important with jets to have screwdrivers that fit the slots as closely as possible. As you'll see, this screwdriver fits that one well, and look, to be honest, I've loosened it already, so I'm not going to fight it. It wasn't particularly tight. This, I believe, is what they call the main jet, and it comes out, and there's a washer under it that's part of the gig as well. So I'm going to just take that out. I'm going to try and do this one-handed and place it over there. The next one is down this hole. Now, I've got a smaller screwdriver that fits across there pretty well, and you feel it's just a I think that's reached the end of its run. I'll see if I can tap it out. There it is. I think that's the one they call the pilot jet. I'm going to line them up here on my computer keyboard. And the last one, which in preparation for the video, I thought, well, I'll do the work on it, was the one out here, which is outside the float bowl, which I believe is the mixture jet, and it adjusts the amount of fuel coming in. And I'll show you that one. It's a needle point. It's got a O-ring below that, and then a small washer, and then a spring. Now, normally what you do with this one is you wind it in till you feel it bottom, counting the turns, and it should be about 2 turns on a quad runner 250. And then you keep that in mind as you wind it out, because when you replace it, you wind it in till it bottoms and then wind it out the 2 turns. But 2 turns is the going rate on them. Now this one was not correctly fitted, so someone's been playing with this, and they've had that out, because when I went looking down the hole where this one came out, or the needle part of it came out, the needle came out, and then a washer, then a spring. No, sorry, we'll start again. It was the needle came out, then a washer, then an O-ring, and then the spring, which meant that when this was fully tightened down, or when I went to wind it in, it wouldn't actually wind in any further, because it was trying to compress the spring completely, and that was wrong. And I only really worked out what was wrong when I went fishing down the hole and found the washer, and then eventually found the O-ring, and then found a compressed spring underneath the O-ring. So this mixture jet has been incorrectly fitted to this, and I suspect that's been done during somebody doing maintenance on the carburetor. I noticed the screws around the bowl were actually, some of them were a bit loose. They weren't nicely snugged up, so I think somebody's been in the bowl before, and probably just to clean it out, probably had the jets out, but refitted this one incorrectly. So it could be contributing to the starting problem that this bike had. There the others sitting there. That's the main jet and then the washer underneath it, and what I believe is called the pilot jet. I'm going to just look that up in the next small clip to see whether I've got the names of those correct. But yeah, we have found a problem with the carburetor beyond it just being dirty. Okay, just checking on the names of some of these jets. This one, which is underneath the diaphragm side, is the last one we're going to pull out to check. Now this one, according to the parts manual, is called a pilot air jet, and that's it loose, and that's it dropped out, and I'll sit it up there alongside the others. It's now we've got a pilot air jet according to the diagram, a pilot jet, and a pilot screw, and a main jet. So that's the names of each of them. And the actual pilot screw that had the spring assembled around the wrong way still seems, the needle part of it itself seems fine. It would not have been seating hard down into the hole in the carburetor body, because that spring wouldn't let it. It wouldn't compress that much. And I don't think it would have been out too far, because it normally is screwed in to within 2 turns of it bottoming out. Now that spring completely compressed would have still had that jet open too much, letting, I think, too much fuel in, and probably causing it running problems. So the other jets I haven't looked through at the moment, but that's the next thing, and I will, and then it's time to give the body of this, internals of this carburetor body, a good carby clean, and see how it comes up. I gave the carburetor a spray on the outside to knock a lot of the dust and dirt off before I began this process, and it's actually looking good, even though when it was wet it still looked a bit dirty, but now that it's dried out it's looking quite clean. So hopefully this carby cleaner spray that I'm using is the reason that's a throttle body and carby clean spray that I purchased for about $7. All right, let's continue on. Okay, after taking everything out of this body and giving it some carby clean, I'm now going to reassemble some of these jets. So the first one is this, I think they called it the air pilot jet. Now, I'm going to do that off camera. Next, I'm going to do the pilot, what they call the pilot jet, in there, and snug it down. These don't have to be incredibly tight, they just need to be snugged up. You can feel them when they tighten. I'm just pushing down and that one's hit its bottom. The next one's the main jet. There's a washer goes on there first, and then you can see the witness mark on that side of the washer, that's the way it went, not that that probably matters. And then the main jet screws in on top of that one. It's having difficulty starting it. I'm going to have to do that offline again. It's getting caught up in the washer. That's it now. Now, I have sighted through each of these jets to see that they're clear, and blown through them. check to see that they're not partially blocked, so they're all good. So this pilot screw I'm going to reuse again. It has the correct order is the needle with the screw on, with the spring, then the washer, which acts as a thrust washer so that the spring's not pressing against the O-ring, and then the O-ring goes on. So, sorry I'm not keeping all of this in shot for you. I'm trying to see myself. But that's the combination that should work. None of those parts are actually damaged, despite them being assembled incorrectly before. So I'm going to reuse that again, even though there's another one in the kit. It didn't feel right. The normal procedure is to wind it in and count the turns. Well, you couldn't wind it in at all, and that's because it was already fully compressing the spring, which was in the wrong position. Now this time I'm going to place that down the tube. The O-ring I think is going to hold things together, and I say that and I think it just fell off, so I'm going to do that offline again. Okay, I've got that pilot screw in that hole, and I've tightened it in till it gently touches the bottom, and it's at a position there where I can count the turns to come out again. I don't know whether I can focus. I'm turning half a turn, one turn, 1.5 turns, 2 turns, which I believe is the right amount for the Quad Runner 250. So that's how you adjust the pilot screw, which allows fuel through. It's not an air screw, it's a pilot fuel screw, and it is fairly critical, and that was the main fault that this carburetor had, was that was assembled wrong with the spring in first, which wouldn't have let that needle valve close up as much as it should, just being 2 turns out. I suspect it could have been up to 5 turns out with it compressing the spring. That would have provided too much fuel and affect the bike's performance. That is the old filter fitted to the new needle seat. I'm now going to fit this new needle seat with the old filter to the carburetor. It goes in there like that and presses down, and the O-ring seems a bit tight. Looks like I'll do that offline. And there's the little screw that goes in to hold it down once it's in. That needed a little bit of a lick to wet the O-ring to make it slip in there. Now I've got the new needle I'm dropping in there, and you'll see just the tip of it sits up there, and there's a little bit of spring in it, the top of that. There's a little plunger inside the needle that maybe takes a bit of the bounce out of the float. Next, I'm going to fit the float and the pin. the float's there in place and the pin is not pressed in. Pin is just designed to push in as a press fit. It doesn't take a lot of pressure to do that. I'll do that now offline. Now the float height looks pretty close to me. The top of that float chamber surface there is, you can see, quite parallel to the top of the float as it sits there, and that's at the point where the float, given this is upside down, when the fuel gets up to a level that pushes the float to that position, it shuts off the supply. You can imagine the float when it's like this and no fuel, you can see the float is down and lets more fuel into the chamber. As it gets full, which is equivalent to me rolling it upside down there, the float moves to a position that shuts off the fuel, and that position is given as a measurement in the book, but basically it's when that top surface, or what is currently the top surface of the float there, is parallel to this surface there. That's the correct level to shut the fuel off. And if it's not right, you play around with that little tab on the float, but I'm not going to touch that. Everything here looks correct to me, so we're just going to close that float chamber up now. The jets in there are tight, there's nothing else, it's clean. I'm going to fit the O-ring to the float bowl. The float bowl, that's the word I was looking for. That's the new O-ring, and I'm going to fit it around and screw that on, including the wire that holds the idle adjustment. It's the longest screw of the four, so we'll do that next. That's the new O-ring fitted to the float bowl. There's the 4 screws, including the long one with the washer on it, and the wire for the idle adjustment. Let's put them on. So that's the float bowl attached. Pretty simple. Screws just snugged up. They don't need to be over tightened. The next person that comes along to remove them, there's a O-ring there that's sealing that surface, so the next person that comes along will be able to get those screws out. That's likely to be me, so let's move on. The diaphragm here needs to be checked for tears. If there's a tear in it, it needs replacing, and it's a fairly expensive part to replace. But I think it's good to keep this carburetor all original, well, except for the Chinese rebuild kit. But no, and things like you can buy a whole Chinese carburetor for $50 or $60, but then a lot of people have trouble getting them going. Look, this is the sliding Venturi, adjustable Venturi that this carburetor works with, and inside that, this needle, and that's the spring cap and the spring. We've got to drop that needle down inside. There's 3 holes when you look through. There's 3 holes in the bottom here. It's the centre hole, obviously, that the needle goes through. We've got to drop the needle from the top down that hole there and poke it through the bottom, and then the spring cap sitting on top of it, and then the spring can be used to sort of hold that in place, and the whole assembly lowered down inside the carburetor. Look, it's definitely a offline job for me to do, so I'll get started with that and get that fitted. Right, that's that diagram and slider fitted back in. Can I point out that this little bump on the diaphragm there orientates which way the slider goes in. You've got to look for the indentation on the casting where that little bump lines up, and that will put the slider back in the same orientation as it came out, and the diaphragm in the same orientation. So that diaphragm now pushes down into this groove, and you can work it into that groove, and once it's in the groove you can put the cap on and the 4 screws, and that's what I'll do now. Look, that's the diaphragm pressed down into the groove. Again, I'm highlighting that little bump there. There's a bump in the casting as well for it, so look for that. If it's orientated the wrong way, I don't know what will happen, but it's not correct. Okay, that's on and snug down, and you probably won't hardly make it out, but there's a slight bump in the case, in the lid as well, to match that indexing bump in the diaphragm. Look for it, because that lid would normally go on in 4 different locations, but the bump is in just one corner, and might be more obvious in the daylight, but that's what I'm talking about. The sliding, you can see that sliding section will spring back to closed quite smoothly. That's the spring behind it pressing it. It's a very light spring. If there's any resistance much in that slider, you've got something wrong, and so it's worth checking. It'll push itself to the closed position even when the carburetor is completely upside down. So there's a nice little check once you put the diaphragm in, that the slider's working properly. You can work it with your finger. Yeah. Okay. What's next? Okay, the next part is this idle adjuster. Where I'm putting the screwdriver there is where the idle adjuster presses on this butterfly, and you can see it opens that butterfly a little bit where I've got the screwdriver at the moment. That's what the idle adjuster does. It screws in from this side and moves in and out depending on where you want you to set your idle. Now, this is fitted with a small O-ring. It seems like a pretty tight fit on there. I'm not going to try and mess with that. I'm going to fit, there's a washer floating on there at the moment. The spring goes on, and then another washer before it screws in. I'll do that offline. So I've got that idle adjuster screwed there, and I'm going to wind it in to show how it works. You can see it's getting longer inside the compartment there as I turn that, and it's slowly opening up that butterfly. It's a fine thread. You're looking for fairly fine adjustment of your idle. I think they want 1350 or something on a quad runner 250, and if you've got a idle speed detector, you could probably adjust that fairly accurately. My guess in terms of a starting point, it should be possibly in that position, where that's usually they design these things where a middle position is where the two faces are fairly parallel, and that's where I'd set it initially to do a trial start. It can be wound further in to move it up, open it up a bit more, or it can be dropped back to, you can see it's dropping back there to nothing. Well, the screw winds away at that point and touches there and starts to open it up there. So let's leave it there and move on. That's the idler adjuster back in its clip, and this is the carburetor refurbished with a couple of items out of a rebuild kit, and a check over generally how it was put together. You don't know who's worked on it in the last 25 years. I don't know how long that pilot screw jet was built the wrong way, but it may have been contributing to problems over the last 10 years with this bike. Look, the little cover off the throttle cable there is out with the kit for when I removed this carburetor, so needs to be off to fit it back to the bike. Same with the choke, so I'll just have this covered so that crap doesn't get into it until it's back on the bike. I'm no expert on these carburetors. I've done one successfully for myself. I started with a similar carburetor off my first bike, and I just cleaned it, reassembled it, and found that it ran pretty well. But I had a leak from the carburetor, and I suspect it was I know that it was the needle and seat leaking, not sealing properly. It did initially, but then a month or so later it was leaking badly. So this needle and seat, I think, needed replacing. I can see a slight indentation or wear mark on the needle. And but look, the biggest problem this one, in my opinion, had was that needle, pilot needle they call it, this one here, that adjusts the pilot fuel mixture. You can get to it from the outside of the bike. Maybe somebody did get it out from the outside of the bike and then fed it in the wrong order, but it would have been out more than 2 turns with the spring on the wrong side and the needle not being able to seat. So I'm thinking that that's one problem that this bike's had, and I'm also suspecting that some of the starting problems may well be related to, I'm expecting that it'll have a valve clearance issue. That's my best guess at what's wrong with it, but we're working towards discovering those things, and this one's ticked off the carburetor for now, so let's move on to another project. So get out to your shed and have some fun.